Hello. So the next application that we're going to look at with similar triangles actually has to do with congruent triangles. So what we have here is a equilateral triangle. How do I know it's equilateral? Well, I said that this side is x, that side's x, and that side's x. Well, if they're all x, then they all have to be equal, meaning they're equilateral. But wait, if this is an equilateral triangle, what does it tell you about the angles? That's right, it's also equiangular. If they're equiangular for a triangle, that means we know all the angles have to be 60 degrees. So that means that this is 60, and so is this one. Okay, and that also means the one at the top is as well. Well, what is that little line that's drawn from this vertex straight down to our other side here? Let's call that a base. That's right, that's an altitude. I know that because it's drawn from the vertex to the base, and it forms a 90-degree angle. Well, the altitude here is 1.73 in length. Well, we need to use this information somehow to find x. Well, from one of the applications or one of the principles we had for equilateral triangles and isosceles triangles was that if we draw an altitude straight down, it bisects this angle and it bisects the side here. So, keeping that in mind, if I know that, that means this is 30 degrees here, and it's 30 degrees over there as well. But we also know then that, hey, instead of that being x, I know each part is x over 2. And I say that now we have enough information to find out what the heck is x. Okay, well, let's find out what x is. Well, this formed a right triangle inside, and that will always be the case when you have an isosceles triangle. When you draw an altitude straight down, you will form two right triangles, and these two right triangles are congruent. They are the same measurements. See this? You have two sides. The altitude is the same as itself in measurement. This x is the same as x. X over 2 will be the same as x over 2. All right. But we have enough information now to set up the Pythagorean theorem because this is a right triangle. We know that the hypotenuse, which would be x, so the square of the hypotenuse is equal to the sum of the square of the length. So the sum of x over 2 squared plus 1.73 squared. Okay, awesome. So when we do this, let's simplify. So exponents first, we end up seeing that, hey, we get x squared equals x squared divided by, well, 2 squared would be 4 plus about 3. And I'm using that because I wanted to use the square root of 3 for this. So we get x squared equals x squared divided by 4 plus 3. Well, what do we do now? Well, we need to simplify this. But I have x's on both sides of the equation. So if you look back at algebra, what we can do is we can move this to the other side or vice versa, however we want to do it. In this case, I'm going to move this x squared divided by 4 to the other side. Well, how the heck am I going to do that? It's adding. So the inverse of addition would be subtraction. So I'm going to subtract x squared divided by 4 on both sides. So I have x squared minus x squared divided by 4 equals x squared over 4 minus x squared divided by 4 plus 3. Okay? And now I can simplify this because this is 1x squared minus a quarter of an x squared, which implies I get 3/4 of x squared equals 3. All right. So we have 3 times x squared divided by 4 equals 3. I can divide by 3/4 on both sides. And if I divide by 3/4 on both sides, I'll end up with x squared equals 4. Okay. X squared equals 4. Well, if x squared equals 4, x must be what we get when we take the square root of both sides. When I take the square root of both sides, I get x has to equal 2. And therefore, that means the measure of this equilateral triangle, the measure of each side length is 2. So this will be 2. This would be 1, because 1 plus 1 will give us 2. And this would be 2. And it actually will work out. That's exactly correct. We would get 2, 2, and 2. This would be square root of 3 here, or approximately 1.73. And when that altitude bisects this side, we'll get 1 and 1. So this works out just fine. So this is using isosceles triangles to split this not into just similar triangles, because they are similar, but they're also congruent. So if you know one side, you automatically know what the other one is because they have to be equal in measurement. So if you have an isosceles triangle, you can draw an altitude, meaning you'll form right angles. And it will bisect this angle up here and also bisect the side that's intersecting. And it'll form two congruent right triangles. Well, we can use the fact that we can use principles and properties of similar triangles, as well as the Pythagorean theorem, to then solve for whatever we want in it. And there's a lot more that you could do with just these two principles. Knowing that, hey, this is a similar triangle, and knowing that, hey, this forms a right triangle, which we'll look at more in the future. So that's another application of similar triangles. I'll see you again soon.